I picked up this Galaxy projector, rather cheap. It apparently has some issue with one or more of the colours coming out of it. Maybe the stars, I can't quite remember, but it's definitely faulty. This particular one can be controlled via a phone app. And I think they normally go for about $80, sort of $60 to $80. I paid $20 with postage, so I thought I'd get this to see if I could make it work again. Yeah, instead of waiting for people to send me stuff to fix, thought I'd just go out looking for it. Let's unwrap it and see what's going on. Here we have the Mirabella Genio Smart Home Galaxy projector. It has a laser with 4 to 700 nanometer wavelength and less than 1 milliwatt, because that's the rules. You can't go too bright in this country, and well, you can't and sell it to the public. Anyway, we got 5-volt DC input and about 1 amp, and what do we got there? 2 gigahertz Wi-Fi only. Alright, so you got to pair this thing with your Wi-Fi. Interesting. I better try and find a user manual somewhere. But there's the business end of it. The laser projects through here, and in here we have looks like some sort of lens arrangement that disperses whatever light's behind that. Oh, let's bust it open. Right off the bat I can see there's 4 little round things that would be covers for the screws. Some of them are not sitting even, which makes me think somebody may have opened it before. Of course they would. And then on this side we have a button in the middle. Must be for setting it on, off, and Bluetooth pairing mode perhaps. Or let's bust it open. Well, actually no. Let's turn it on and see what the problem presents as, so we know what we're looking for inside, I guess. It appears it may have been fried beyond belief. You know how we said 5 volts on the sticker? Well, this adapter that's been provided is 12 volts. So that's not a good start. It definitely says 5 volts there. Doesn't give me a polarity, but we can safely assume positive center. I think we put 5 volts on it and see what happens. Now, if you don't know if your plug is any good, obviously you can get different diameter center holes there, and if you want to know if it's connecting through, just plug it into your device, pop your meter into diode mode, and one way almost always gives you a diode reading. See, we have 0.14 volt drop. That's pretty low for a diode, but it could just be one of those rectifier diodes. And if I swap the leads, we have 0.14 again. Interesting. Okay, so now we don't know what's what, really. What sort of resistance do we have? It's not entirely foolproof then, perhaps. 100 ohms. Ah, okay. 100 ohms seems a bit low. It's in both directions, of course. Maybe that's legit. 5 over 100 is going to be 50 milliamps. Well, I guess all we can do is plug it in and find out. Well, we're getting a reading, which means that our plug is making connection with the center pin. And now I just need to remind myself, is the striped wire the positive or the negative? I don't remember. Let's go to the striped wire as positive. Meter and center pin, positive. Here we go. So with our power supply leads clipped on accordingly, we'll plug it in and turn on the power supply. 5 volts, I've got to set at half an amp. I might just pop that down to 200 milliamps just to see what happens, and turning it on now. Okay, it's drawing the 200 milliamps. Okay, if I crank it right up, then it's drawing half an amp at 5 volts. If I set it to 700 milliamps, so it's peaking out at half an amp. Cool. Don't appear to have any laser coming out of here, which I think was actually half the problem, as it wasn't showing the laser dots. Hopefully that hasn't been fried the laser diode as a result of having 12 volts in it. But at least this is working, and the current's fluctuating slightly. Anything moving internally? Really see a lot going on the ceiling. So that's what it is spewing out at the moment. I'm pretty sure it is not changing. Okay, let's crack it open. What do we got here? Little silicon inserts. Yep, they come out nice and easily. Just reach for the Phillips without even looking down the hole. What a guess. Okay, that's lifting off, and I felt something drop out of this half, so I'm wondering what's staying behind. It looks like the lens is staying behind, which is good. That's what I wanted. Let's get down and have a closer look. There's bound to be something attached to something. Oh, no, that's upside down. I will tip it over, and less risk of things falling out. There we go. Oh, okay, so the lens just dropped out to the other side. Cool. So what we have here is before, but let's just unplug that, which I can't because it's glued. Well, that's a good sign. It's still glued in, which means someone else hasn't been here before. And here we have the guts of it all. Pop that. Oh, there's the lens. I'll leave the lens aside. There we go. We have a rotating piece of glass. There's a really cool thing you can do if you have patterned glass like that in a door, wherever. If you shine a laser pointer at it, what comes out the other side creates quite a neat pattern on the wall or the fence or whatever you're pointing it at, and you can just rotate the glass or move the laser pointer and get quite a good light show very easily. This has another piece of glass behind it actually. There's a rectangular one, that's interesting. The round one, obviously it's supposed to rotate. That's what I thought the current draw might have been. You can see it's got a shaft going through the middle. There's a gear here. There's a motor here. And that's suspended with a little sort of a peachy coloured rubber mount down in the middle. And then over this side we have there's a heatsink there, and down the middle is our laser diode. That is set up to shine through the center of this gear. It's hollow tube through the middle of this gear, so this tube rotates, which causes the aperture there with some sort of diffusion plate on the end, and that rotates in front of the laser beam itself. Does this have a second laser, or is it just LEDs? I think it might just be LEDs lighting up behind that glass wheel. There's the PCB, and we have our laser diode being the green connector at the bottom, and the motor is the white connector above, and this goes off to the other LEDs. Okay, so we need to have a close look at what's going on there. Does the laser diode have power going to it? And let's hope it just hasn't blown the laser diode. because this will be current regulated, so maybe the regulator has failed. I'll just gently encourage that out. So the glue still attached. Now, laser diodes are, I'm led to believe, static sensitive. I haven't yet blown one up by accidentally touching the pins or wires or so forth. But I guess use caution as you will. Let's have a look at this just to see what's going on the other side. If there's anything going on the other side, I can see this looks like a Wi-Fi module hanging off the back, but we'll see if there's anything burnt looking. It looks pretty good on this side without doing any tests. And what have we got? Well, fancy that. Can you say, let the magic smoke out? Boo. Let's hope we can get a number off that IC. But if we look roughly where it's aimed at, it does look indeed like the laser current driver. Oh well, let's hope it died to save the laser diode. Oh no, the other chip up top here has a bad mark on it as well. Oh, there's two ICs down the tube, and they look special. They don't look like a MOSFET package. Whap, whap, whap. There's an inductor. One of them's going to be a switching IC then. The other one is going to be, I guess we'll find out shortly. Annihilated. That IC and that IC, which is U7. And things should be running on, we got, well, you can see it on the PCB, blue lead, red lead, key, so that makes sense, and 3 volts happening in the system. It should be this is our 3 volt regulator, 3AMS1117. I need to find out what that IC is, or what they both are, to be honest. So out with the old alchemy. We'll see if we can wet it to a point that helps identify things. I can see like an X in the top right. Oh wow, it's got so hot it's desoldered. Check that out. It's actually lifted the legs off the board. Must have swollen up underneath. Wow. Something, oh, 7, oh, yep, get the right light, 7, is that a 1? I think it is, C7140. Right, we start in the old Google and we'll type in C7140 data sheet. And what comes up? First result, AMC 7140, high voltage adjustable current regulator. Well, I think this is our switching regulator, current regulator. There you go, because there need to be a current regulator to properly power a laser diode. Well, close. Maybe it's a different package of C7140. Let's try that again, shall we? So after a bit of digging, I tried 7140 SOIC8, which is the package size. And here it is, because I can faintly see, this is OCX, can I zoom in there? There you go. This is OCX, because you can definitely see the X melted and half the C and barely any of the O, but that's the logo that I can see. So it's OC7140. Old faithful AliExpress. Not many sold, but they exist. And only sort of $5 to $7 for a bunch. So what do you notice about this IC? Other than it's been entirely laser etched off. Boo! Boo! Oh well. There's nothing we can do with that. The laser diode, where is that getting driven from, out of curiosity? It's those two pins there, which has a diode in parallel with it. Laser plus, laser minus. And that goes off to there and there, which is there through that resistor down to the little device there. I bet that little U8 is our laser constant current supply. Maybe that's damaged as well. Oh look, there's one. There's an OC714 not melted. What's that one doing? That appears to be... Oh, there's another one. Oh, they're everywhere. Ah, okay. Or maybe those ones are driving the RGBs. So one for each color. So we've got red and blue, so it looks like this must be the green one that's gone out to lunch. I wonder if we can piggyback the green LED off of another one of those regulators. Maybe, I mean, this is clearly a microprocessor, a little microcontroller that would have been doing some funky stuff, like turning on the motor for spinning the disc, little glass wheel. Where do those wires go? That goes up to there, and that there, diode there, into, oh yep, so this, you can see this comes up from that micro into the base there, which will be turning this on, which is going via, you know, there's a diode there, and that snakes off down between those connectors to the motor connector. So that's our motor control there. There'll be laser diode on off signal, comes from that pin, goes through the board there to there and around and down into here, the laser driver. So I'm picking that's an enable signal. Maybe I should just plug it in and see what's going on. I might just remove this, both of those dead ICs actually. It's kind of pointless having them on there, it's just a hazard. Probably welded a bit to the board, especially that pad over here. We'll see if it comes off in one piece. No, I don't think it's gonna. It's not gonna. So let's take this one off instead. And I will just cut that leg that's hanging on to preserve the trace. And then we'll desolder the rest of it. This is what you get when you take a gamble on stuff, when idiots put the wrong power supply into it. So if I plug it in now, technically nothing will happen except those red and blue red and blue LEDs. But we can see if we can. I don't think we'll be able to connect to Wi-Fi, I don't know. I'm curious to see if the laser diode still works. I just set my current limit to about 50 milliamps on the power supply and wound it up until I had 6 volts, and when I hit 6 volts You can see those stars appear all over the face of the power supply. You can see the green dots all over the place. So I will plug in the board again and we'll just see what sort of current draw we get. And we're getting 130, 140 milliamps. Let's see what we're getting for a voltage on our 3-volt regulator. And if we go to our regulator, we can see there's 5 volts there, 3.3 coming out, so that's good. Out of curiosity, I was wondering if these ICs, the LED driver ICs, ran off the 3-volt line, and I was just, there's the 3-volt comes to here, and it doesn't look like they do. So let's check, do they come off directly off the 5-volt line? And they do. So we're quite lucky that this is the only one that popped. Maybe it overloaded the power supply so that it didn't damage the rest of them. But these are all on the 5-volt line, so having received 12 volts directly is a fluke they didn't burn up as well. Pin 2 of these ICs is a PWM input, which is used for dimming. And it looks like that's run off to this wad of transistors over here. So maybe they are multiplexing somehow through there. They could be multiplexing the dimming signal with the data signal and all sorts. I don't really know. I just need to find where the enable for that laser diode goes. Oh yeah, it is that corner. Okay, so I have no voltage on the laser diode driver, so there's no way I can enable it. Okay, so if I put my meter on the base of that transistor, it actually turns on, and now it's rotating. Noisy little thing. I don't know if you'd want that in your when you're trying to go to sleep looking at galaxies and this thing's grinding away. Oh, now it's always on. Oh, it's probably floating because it's not connected to the little micro anymore, so that base is floating. So alright, maybe it's actually a MOSFET and it's not shorted. I just I turned it on by probing the gate source. Yeah, alright, okay, maybe we can rectify this somehow. I still haven't got to see how that laser diode driver turns on. So I found a data sheet for the laser diode driver, which is a generic LED driver, and I was right about the enable pin. However, it is switched off because there is no voltage being sent to it. So there's the inductor. It actually runs on the 5-volt line, and the 5-volt comes through the inductor to the switching pin, but also to the VN of that IC. And what we have here is the inductor on the other side comes through to, I think this must be a PNP perhaps, but the center pin of that transistor, with the other side of the transistor being connected to our 5 volts. So 5 volt comes through the transistor when the micro turns this on. So what we can do is just jump a wire across the collector emitter. We'll just jump a wire across there to there to have it always on. You gotta work quick, otherwise you heat up your wire and it desolders itself from the other end. Jump the two, and that should provide. I should have laid that down so I can do this and work on it without bending it. That's fine. It will be okay. I won't press on it too hard. We've got our switching pin bottom right. Then we've got ground and enable heading up that side, and then on this side we've got VN and over voltage protection and enable. Enable is a logic 1. I wonder if it has to be, I suppose the 3 volt would do the same job. So I just need to find 3 volts. Jam it on there. And we've got our 3 volt there. That's not going to interfere with anything because this is just a cutout for the gear to rotate in, so it's not going to get anywhere there. That'll do. Having you aimed at where it's likely going to project to, let's plug it in and see if it does. And on. Hey, we have stars. Stars in their eyes. Alright, we're halfway there. I could just stick a bunch of switches in the side of this. You can just manually turn stuff off and on. That'll work. I don't have that many switches though. Well, I guess that's pretty much the end of it. We can't repair this to be as functional as it used to be with Wi-Fi connectivity and missing a LED driver, so I think that's the end of the repair attempt. Yeah, one poorly made device that really should have had some sort of over voltage protection when they've got a DC jack that's you can plug anything into, to think that people are going to keep the original adapter. Some people know, some people don't. That, you know, some people think that those adapters are all the same. They'll just plug anything in, move house, throw it in a box, mix them up. It happens. So it'd be nice to see manufacturers actually putting some sort of protection in for the longevity of the device. And especially since it's a kid's toy, they don't necessarily know the difference between adapters as well. So if they move it around and pick the wrong one, well, thanks for watching. Stick around. We will perhaps do a video on a bit more reverse engineering and can we make it work again with a different system. Catch you next time.